Thanks for joining us this afternoon. My name's Sergio Pineda, and I'm with Docker. And today, we have the pleasure to have Citizens Bank. Don Bauer and Mike No are going to walk us through their story of mission-critical migration. A couple things. Don and Mike are actually in a Q&A panel immediately after this session. So we're only going to limit questions to 5 minutes. But if you want more insight or questions regarding their talk, just go to their Q&A session, which will be immediately after this, and they can tell you where they're going. Okay? So with that, guys, who's going to go first? I'll let you guys take it away.
We'll take it from here.
Okay.
Thank you, Sergio. Hi, everyone. Like Sergio said, we're going to talk about mission-critical migration from Swarm to MultiCluster Kubernetes with a handful of our services using Docker Enterprise. Some intros first. My name's Don Bauer. I'm the lead DevOps engineer at Citizens Bank, and I've been a member of the Docker community now for about 2 years as a community leader, and as of last week, I'm now a Docker captain as well. I run meetups and organize conferences in Nashville to help spread DevOps, spread Docker, spread containers. I've been in the industry now for just over 12 years.
I'm Mike No. I am also a DevOps engineer at Citizens Bank, and I have been using Docker for also about 2 years. I've been an admin and engineer pretty much my entire career, and really get into DevOps and automation over the last 4 or 5 years.
So, I almost said it earlier, Franklin American Mortgage. I wanted to clear up some stuff because we've had some questions about it, just super quick. So when we started our DevOps journey, we were Franklin American Mortgage. But recently, I believe in August of this year, we were purchased by Citizens Bank. So if you hear us say one or the other, it's actually the same thing. But I'll try my best to keep it consistent. So let's start with some backstory. We summarized a lot of this in our talk in San Francisco at DockerCon earlier this year. But we still wanted just to briefly cover some of it here. So the first thing is, why did we choose containers? For us, we started an innovation initiative, and the initiative was to change the way we build and delivered software. We needed to speed up, we needed to reduce the feedback times, and we needed to make sure the products we were building would work. More importantly than that, we needed our apps to be able to run anywhere and everywhere. So we were wanting to avoid vendor lock-in. Most of our stuff does run on-prem, so we couldn't use cloud providers. And when we do start expanding that route, which we're expecting to here in the future, by using containers, we didn't have to worry about differences between them running on our local machine versus on-prem or the cloud. And lastly, we needed a way to package all of our applications in the same standardized manner. So whether it was written in Java or Go or it's a UI, we needed a way to standardize how we were going to produce those artifacts, and we were able to do that with containers as well by putting them all into images. It simplified the CI/CD pipeline, our build processes, all of our automation significantly. So the next thing is, why did we choose Swarm as our orchestrator? The first piece of that is we chose Docker Enterprise. And we chose it because it was batteries included. It came with the Swarm orchestrator, which was one of the things we were really looking for. And in addition to that, it comes with UCP and DTR, which you guys, I'm sure, have seen a lot of, over the course of this conference. The biggest thing, though, beyond that, is Swarm is simple to set up. It's easy to maintain. And we needed the ability to manage and maintain this cluster with a small team. And when I say a small team, it was one. It was one guy that had to maintain this whole container platform that we were building for the company. The other big piece around security was complete isolation, especially on the networking layer. So we were able to stand up staging and test and prod on the same cluster and ensure that we wouldn't have any crosstalk between those environments. And along with that, we were able to set up simple affinity rules to ensure that production workloads were running on a dedicated set of production-only hardware, while everything else shared the rest of the cluster. One of the testaments to how simple it is to maintain and deploy, we have to stand up a 25 node cluster every now and then just to run through some tests for upgrades or global services. We can do that now in under 30 minutes using the Docker certified infrastructure or DCI templates. And we're able to get away with that because of Docker Enterprise and Swarm and how simple it is to set up. So I'll let Mike take it from there on Kubernetes.
So now that we've had Swarm and we're starting to look at some of the other orchestrators and how we would go about doing this, Kubernetes is one of the next options, obviously, because it's shipped with Docker Enterprise as of 2.0 and 1.12 with 2.1. One of the reasons that we're looking at Kubernetes specifically is because stateful services can be difficult. They can be frustrating to configure and maintain. Kubernetes has things like operator patterns and some other automation that's sort of baked into the system to help us do some of those. We needed the ability to absolutely scale vertically and horizontally with some of our more complicated services that we'll actually go into later and show you what we did to get those there. We really like the operator patterns here. They really change the way you can manage the orchestration and the scaling. We can automate a lot of this with Swarm, but the operator patterns give it to us by default, so we thought, why build it? Some of our vendors actually only support Kubernetes deployments. We have some third-party applications where we bought support for them, and they're like, we will help you only if you have it on Kubernetes, not Swarm. Finally, the Docker Enterprise supports Kubernetes as well, and we love the support we get from Docker Enterprise. The folks over there have been absolutely fantastic in helping make sure that we stay up and reliable as much as possible. If you're here, you may be interested in some of the business value that comes with running Docker Enterprise or Swarm or Kubernetes. And as Citizens colleagues, one of the business value to us is customer value. And for us, that means treating our customers, taking great care of our customers, helping to grow the business, and to, I'm sorry, I forgot the other ones. Sorry. And we can do that. Being disciplined with our expenses was the last piece, I'm sorry. Being disciplined with our expenses is another value from Citizens. And we can do that because Kubernetes comes with Docker Enterprise. We don't have to buy anything else. We don't have to do anything else. And you guys have probably heard this word a lot, but synergy. Kubernetes, containers, Docker Enterprise is another way of helping us do more with less. And that's what it's really all about. Every year we get better and better with technology. We can do more and more. And Kubernetes with Swarm inside Docker Enterprise lets us do that day in, day out. Automation and the way the APIs are built into Kubernetes really is the backbone of why we chose to go down this road here. It helps us, again, do more with less. We're automating more. We're having to be less involved with the applications. We're getting more done.
So, like Mike was saying, with the automation, both with Swarm and with Kubernetes and kind of how we've started building out our platform, we've been focusing on doing more with less. But that doesn't mean we won't need more. And that kind of is what started us down this path, where we were exploring things like Kubernetes. When we first started, we had a very, very simple supply chain. And I'm sure some of you have seen this slide before, but we have our developers, building out their applications on their local machines, testing them using Docker for Windows or Mac or Linux, and they'll check their code into source control once everything's ready. Our process will automatically push that new DTR image, and then through CI/CD processes, we can then deploy those through our non-production environments and then eventually promote them to production. To be a bit more accurate, this is what it looked like when we first started. So we were running test and staging and prod on one cluster, and again, with the affinity rules and everything we had set up, they were all sharing resources but still maintained completely isolated. So what's happened is we've started to grow, and other teams within the company have started to containerize their services and start to take advantage of our new DevOps processes and containers as a whole. Is we needed more. Just because we were doing more with less didn't mean we didn't need more. So we went from one cluster to many. Now we have multiple non-production environments, and we have a mirrored production environment. And the way we've had to kind of change everything to support that was actually very, very simple, just because now we don't have to worry so much about non-production isolation when we're testing Kubernetes services. So we're able to have a test cluster. We don't have to worry about crosstalk on the Kubernetes side. Same thing with staging. We also have an operations cluster. I'll touch on that a little bit here later, but that's production supporting tools only. So going from one to many, our process didn't really change that much, but now we had to handle deployments to multiple clusters, promotion across those clusters. And with UCP and Docker Trusted Registry and Notary and Docker Content Trust, we've been able to secure that supply chain from end to end and still keep it really simple.
These are some considerations that we went through before we actually started migrating into Kubernetes. It was the very first thing is complexity. If you've dealt with Kubernetes at all, and Swarm, you know that Kubernetes can be way more complicated than dealing with Swarm, especially when it comes to the networking. The security, how secure are our containers going to be? How secure is our orchestration going to be? How secure is the platform itself, really? These are very big pillars for us.
And we've already covered it a few times, but isolation. So making sure things can't crosstalk or talk across different environments.
Some of the challenges that we faced, again, we're going to talk about networking, ingress handling. How do we handle services from Swarm talking to Kubernetes, vice versa? Securing the containers, the container access. These are things that we had to fix. We had to figure out how to get there. The environment data segregation, this is hugely important for us. And of course, we solved that by breaking it into multiple clusters. Making sure that we could fit all of this into our existing CI/CD deployments, using GitLab the same way, using our DTR in the same way. And figuring out the communication between our Swarm and Kubernetes services. Making sure that we can run all of these without necessarily exposing them to any type of unnecessary threat.
So with those considerations in mind, there's also some benefits. And when we were going through different things, trying to figure out, should we move some of our stuff to Kubernetes? Should we introduce it into our ecosystem? Some of the things that we looked at, first and foremost, as I blank out the screen, Helm!
Helm!
So Helm, I'm sure I don't need to explain it, but it's one of the things we were very, very excited to introduce to our workflow, being able to build and package applications that might have multiple containers or need to scale in a very simple way that we could share them outside of the company with the community or inside and handle all the deployments in the same fashion. The next big thing, of course, was the fact that all of this is now included and supported with Docker Enterprise. So again, we didn't have to change hardly anything to add Kubernetes to our workflows. And now our developers and our operators have the choice when they're deciding to develop a new service or product that needs to run within our ecosystem.
Yeah. Community support is one of our favorite things about Docker, and even in Docker Enterprise, the community is doing so much every single day. There's very little we had to figure out kind of from scratch. A lot of the things that we did were around being on-prem, like with vSphere and NSX. The native plugins that are coming, and there are more and more every day, make a lot of this really, really much easier. One of the things, let's talk about using vSphere and NSX. We use an NSX plugin with our Kubernetes cluster to help spin up load balancers on-prem, just like you would in AWS. And of course, having all of these components in the same place with UCP, we have Swarm there, we have Kubernetes there, we have all of our storage needs and everything in one place. Means it's really easy for us to store, track, and report on all of these changes and operations that happen throughout our platform.
So once we had decided to move forward with introducing Kubernetes as an option for our developers and for people that were going to be running applications on our platform, we kind of had to take a step back and reevaluate the services we already had running and figure out where we should start. And so we did that by identifying our biggest pain point, which is scaling stateful services. So we took a look at a lot of our technologies that we're using, like Kafka, Zookeeper, Cassandra, Schema Registry, and Elasticsearch, as well as the ELQ stack as a whole, and figured out where the best place to start was. So what we did is we chose what we thought was going to be the hardest one, and it's also easily the most critical in our day-to-day operations and support of all of our containerized environments, and that was going with the ELQ stack. So we chose to start here because we figured if we were going to run into problems anywhere along the road, we would run into them here, and we would be able to take all those lessons back to all the other services as we started migrating those over. Just for a little bit of a disclaimer, this isn't going to be a super technical talk. It is more of a story, but we are going to cover some of the specific challenges and things, and everything we were really disappointed about not being able to demo or show in detail, luckily enough, has already been demoed or shown here, both in the keynotes and a number of the sessions. So first, let's take a look at what our ELK looks like. So his name's Eddie. He comes to the office from time to time. No, I'm just kidding. All right. So for real, we're taking a sample here. So we've got our 3 clusters, our testing cluster, our production cluster, and our operations cluster, which I mentioned before. Of course, each of those clusters are going to have any number of nodes. And on the test and prod cluster, we're going to have our containerized workloads that are, running our services and everything. Within the operations cluster, we've got our Elasticsearch. I don't want to say the word cluster again. A 3-node Elasticsearch deployment, and then a 2-node Logstash deployment, and of course a 2-node Kibana deployment. So all these services work together along with FileBeat, which needs to be installed on every single node in every single cluster. Now, where this started to get complicated is after we went through and evaluated our processes or our services rather, that needed to be migrated, we had multiple orchestrators in the mix. And in this case, it was within one cluster. So all of our Elasticsearch and Logstash, we're running that on Kubernetes, but our Kibana, we're running on Swarm, and all that's within the same cluster. And then you look at services like FileBeat that need to be deployed everywhere. So we'll cover some of the challenges we ran into trying to get that set up across multiple clusters running multiple orchestrators. So the first thing, Elasticsearch, I'm sure most of you are familiar with it. We use it as our storage backend for logs and some metrics across all the clusters. We do have one centralized Elasticsearch deployment within our operations cluster that supports every one of our containerized environments. So this one cluster is supporting, if we have 6 clusters, it's supporting all 6. If we had 100, we might reevaluate how we have it deployed, but right now it would be supporting all of them. One of the big things with it is we needed the ability to scale it properly. So if we needed to add a node, that involved provisioning a new volume and getting that set up, getting the cluster reconfigured so it knew the new node was there. And in addition, we needed the ability to add new clusters on demand using the same template. So if we needed to stand up a second cluster for whatever reason, right now it would have been a copy and paste operation. We have to manually provision those volumes and things. So with this, we decided to migrate it to Kubernetes. To highlight kind of what we're talking about here, here's a sample of the Swarm template. This is available in a public repo that I've got linked at the end of this presentation. But you'll see on the left, we've got the first Elasticsearch service defined. And it's a pretty standard setup. There's only a couple configuration differences between it and the one on the right, which is the second node in that Elasticsearch cluster. Really, the only differences between the two is a little bit of configuration, which we could solve with a configuration management system. And then the volumes, which was really the biggest pain point when it came to scaling. So if we were to keep going, you'd see that there's Elasticsearch 3 and 4 and 5 and so on, and every one of them's kind of copy-paste. And we didn't like that. It's not a viable solution long term. So going to K8s.
That's it. Obviously, we started with an open source repo on GitHub, and we reconfigured it, repackaged it, and now we can scale our cluster up and down with a single command.
Yeah. So this is a sample. We didn't actually run that, but it was
Yeah.
it was about that easy to deploy once we got the variables and stuff in there. So next up we have Logstash. This is our data processor for handling log ingestion from all the clusters. In our case, we're running it in a replicated mode using persistent queues. So again, the need for being able to scale with automatically provisioned volumes came into play. We receive and process logs from hundreds of systems across the rest of the enterprise, in addition to every one of our nodes in all of our clusters. So with this one, we had the same need. We needed the ability to scale it with automatically provisioned volumes in the same way as Elasticsearch, so we decided to migrate it to Kubernetes as well. And I won't bore you with the templates on this one, because we'd be highlighting the same stuff. Next, we've got Kibana. So Kibana, of course, interface for searching our log entries. We use it for dashboards and reporting. All of our weekly and monthly metrics that we send back and review with our management and corporate and all that come out of here from the data that we're gathering. With this, it runs as a completely stateless application. So it doesn't have any persistent data that needs to stay behind. The containers can truly be completely ephemeral. They don't need to pick up where they left off. So with this, we decided to keep it on Swarm. We felt that there was absolutely no reason to move it over, because we've already got every one of our needs met.
FileBeat is another service that we had to consider. It's part of our Elasticsearch stack. It's a distributed, lightweight log shipper, meant to go out there and gather all of your logs from every container and our nodes as well. Performs all of our initial filtering, and you can see it uses Docker D to dig down into the actual containers effectively and efficiently. This one's sort of semi-stateless. By that I mean it has a single file that it keeps locally. And FileBeat is unique because we have to actually run it on everything. It's because we're running Kubernetes and Swarm simultaneously, we have to be able to pull the logs from both containers orchestrations simultaneously.
Yeah, as our log shipper, it of course does need to run on every node, but when you're talking about mixed mode orchestrators like you get with manager nodes automatically, and at any point in time you can switch any of your nodes in a UCP cluster to mixed mode. I wouldn't do that for production, but it's great for testing. But I think it even says, don't do this for prod.
Yeah. Well, because the biggest thing is we do that with FileBeat. Swarm and Kubernetes will install FileBeat twice.
Yes.
They'll both try to install FileBeat when we run this. And so make sure that your nodes are running one way or the other.
So to get around that, we took our already incredibly simple Swarm template or compose file for FileBeat, which you see here. And it looks like I forgot to add the label constraint, but the one thing that we added to that template was a simple label constraint that said don't run this on mixed orchestration nodes. So we didn't have to worry about that when we get to the Kubernetes side, which
again, Helm. This is one of our favorite things, and you can see here we use basically we can deploy it from just a directory with a values.yaml locally, and we can manage that values.yaml a lot easier than we could managing all of the Swarm templates.
Right, and so since we did the node constraint on the Swarm side, we didn't have to worry about things like setting up Kubernetes taints to prevent those from running on certain nodes. So we just let this deploy the same standard way any other Kubernetes service would.
Yep. So before we get to the summary, let's take a moment to talk about some of our stats from our ELK environment and some of the things that we're processing on a daily basis. We're pulling in over 60 million log lines a day, 800 entries per second across all of our clusters. A little more than a terabyte a week. Obviously, we're not keeping all of this data. It's about 1 billion entries that we have to search through at any one given time. And Kibana does a brilliant job of presenting all of this information for us. This is one of the coolest things about this is that from the time an event occurs and to the time that we can actually see it in Kibana, it takes about 1.5 milliseconds. That is near real time. And that is absolutely fantastic for production applications.
Yeah, especially with the later versions of Elasticsearch where you have the virtual tail -f option now. So with that low of a latency, it's been a huge help for developers and operators troubleshooting these services. Not these services, but any services running on the cluster. So we wanted to cover just a little bit of our process stats too, because our ELK environment is what enables us to do what we do and actually promote this DevOps culture across the organization. So it's helped us achieve roughly 100 deployments every day. We're standing up 2 new environments every week, self-service. Most of the time those environments are ephemeral and they're gone by Friday. At any given point in time, we're running about 2,000 containers across all of our clusters. And with our persistent services, roughly 10% of them now have been migrated over to Kubernetes to add features like we've discussed our need for today. So to summarize, I'll let Mike take off with this one.
Essentially, we love Swarm, and it's our default mode of operation whenever we get a new service or we're tackling it like a legacy service. And so for the most part, if it's a stateless service, we're going to continue to put it in Swarm. We're not going to redo everything we've done in Kubernetes. If it's stateful and we have a hard time getting it to run in Swarm, then we're going to move it to Kubernetes. And like I said, Docker Enterprise really is the best thing that's kind of happened to us. We love the support from Docker Enterprise. We love the fact that we can run both orchestrators. And it is the reason that we're up here today.
With that, we really wanted to cover the flexibility. So we had struggled with this decision when we were first getting started. We had identified Kubernetes as something that could probably meet our needs. But with Docker Enterprise, we chose it for simplicity, all the other awesome features that I won't bore you with. But since we already had it, adding Kubernetes in, like we've said 100 times, it required no effort on our part, and it now allows us to offer the flexibility so our developers aren't locked in to one orchestrator or the other. We can use the right tool for the problem. And last, standardization. So if you've seen any of our DevOps talks or our conference in San Francisco, you'll know standardization is one of our most important tenets. And with this, we were able to maintain and keep the same standard we already had. We could deploy all of our services the same way, but now they had an extra option for which way they were going to go about orchestrating.
So if you're going to be taking this path, there's a couple of things we'd like you to consider before you get started. The biggest thing is determine your philosophy. And with that, I'll also say determine what's paramount. These 2 things will go hand in hand in making sure that you're making the right decisions early on to get to where you want to be, right? Our philosophy comes from being simple, having the ability to experiment, having it standardized, and giving us great visibility. And all of those things led us to make more decisions about getting to Kubernetes. Have a very, very clear goal about what it is you're trying to get from Kubernetes. We knew specifically when we started down this path that our goal was to make some of our more difficult services more reliable, right? To have a better overall platform for our developers and our customers.
On that, as part of our final thoughts too, the thing I want to emphasize is if you are using Kubernetes and someone comes up to you and says, hey, why are you guys using Kubernetes? We don't want your answer to be, because my boss told me to.
Or because Don told you to.
Yeah. Make sure you evaluate it, try new things, experiment. Experimentation is another one of our big tenets that we talk about a lot. Kubernetes is a great tool. It's very flexible, but again, it's a bit more complex. So make sure you define your need and try it out, because I know we started over probably 5 times before we kind of got our process nailed down and figured out where some of the gotchas are. But on that, make sure you're engaging with the community. The Docker community is great. The Kubernetes community is great. There's meetups, there's conferences, there's workshops all over the place. I'm sure I'm probably preaching to the choir. But I know that was our biggest help, was engaging the community. The Docker community Slack has been fantastic for helping us along this path. Docker Enterprise support's been great. With that, I think that finishes my final thoughts. We do have a links slide, and I know these will be shared at the end. So we did want to link to our talk in San Francisco. We did 2 DevOps webinars, one with Instana and one with Docker. And then the Angry Elk repo that I mentioned earlier has all of the Swarm templates we've mentioned. We have the Kubernetes side of that ready to get put in there, but we're still waiting for official sign-off. So that should be up very shortly. But if not, I mean, it's still there, a great resource for all the Swarm resources we spoke about. And a shameless plug, we're hiring. So we're always looking for skilled technologists, people that are passionate about trying new things, experimenting, helping push the envelope. So if you're looking for a change or you're looking for work, we're hiring. So with that, I'll let Sergio take it away. I think we actually have a little bit more time than.
So what's your hard stop? Do you want to be out of here right in 10 minutes, or?
I think if we go straight up to the end, we're probably all right.
Yep.
Okay.
We got about 8
So questions. So we have about 10 minutes for questions. So she had her hand way in the back, so I'll start in the back. So we give everybody an opportunity. Try to limit to 1 for now. Okay. Thanks.
Why did you pick Kibana and not Grafana?
Well, to be completely honest, we are using both. So for Kibana, it was a technology that our developers already knew and our operations engineers already knew for searching the logs and getting the aggregations. We are using Grafana as well. Within our organization, it's part of a separate stack, and we're using that solely for metrics along with our Prometheus deployments. So it was kind of outside of the scope. So we didn't choose one over the other. We're actually using them both. We just have them siloed for their specific purposes.
Thank you. Okay, who's next? Don't be shy.
Sergio, I think he was first. Oh, there we go.
Hi, thank you for the presentation. Do you have only on-premise cluster or managed clusters in Kubernetes?
Say again.
Is our deployment or infrastructure only on-prem?
Only on-prem?
Yep, only on-prem.
Yes.
Okay. And second question, tell me more about your securities, because a lot of cluster, but nothing a word about securities. I think it's pretty interesting to see, because you're a bank.
That's a very big topic. If you want to find us afterwards, we can break it down for you a bit more.
Okay.
Okay.
I think you had your hand up.
Why did you deploy Elasticsearch in Kubernetes? There's ways to increase the number of nodes in Swarm as well, using self-discovery. So I don't know why you used Kubernetes.
It was the biggest proponent was the volume portion of it. So with our when we needed to scale a node up, we needed to make sure that volume was prepared ahead of time and available, and we can't just increase the replica count the way the service was built out. I had a second thought on that too, and I just lost it.
It's mainly about the scalability and reliability. And so the volumes become complicated in Swarm when you're scaling stateful services like that, especially when the configs need to be rewritten every single time.
We have discovered a few other ways in going through this that we could have accomplished what we were doing, why we were moving to Kubernetes with Swarm, but it wasn't a solution for all of our other services that we were looking at as well. It did seem very Elasticsearch specific, but we actually have action items when we get back to go back and review those more.
Hi. I think you are the first 2 guys that I meet that you have used Swarm and Kubernetes in production.
Yes.
Both of them. So I will have a lot of questions, but I'm going to ask one. What do you miss from the both of them? What functionality would you like to see that neither Swarm and Kubernetes have?
That neither have?
I don't know that there is such a thing. I don't know that we've run into anything like that. We started with Kubernetes specifically because it was going to be available to us with Docker Enterprise, and it gave us another option to do things in maybe not a I don't want to say less complicated way because Kubernetes can be complicated. Let's talk about that afterwards. I'd love to sit down and talk about that. There's a lot of stuff there.
Yeah, I think between the two, so far we really haven't run into a situation where we've needed something that neither of them does.
This guy right here, Sergio.
Okay.
He's trying so hard.
Yeah, because let's be
Hang on.
okay. Let's be serious. Kubernetes on-premise, especially with regards to persistence, is a pain in the ass, right?
Absolutely.
Okay, so and you guys are running on vSphere, right?
vSphere 6.0, yes.
How are you guys dealing with the persistence with storage?
So we have pure storage for all of our containers. We're using pure block storage for all of our container services.
What kind of storage?
Pure, it's a pure block storage. Pure is the vendor.
Yeah,
Okay,
it's an NVMe-based flash array that backends all of our block storage for our containers. And we've been working on a case study with them, actually, that they were hoping to have ready in time for the conference, but it'll be out here pretty soon, too. So.
Okay. Okay.
Good question.
Okay. Okay, who's next? Yes.
Hi, so it's very easy to install stuff with Helm. It's actually too easy. So how did you harden it, especially in your CI/CD pipeline, or how?
So we manage the packages for Helm, just like you would with anything else through GitLab CI. And so we can maintain those as like, either from the operations side or developer side. So.
Okay, and yeah, who's actually able to install stuff on top of your Kubernetes clusters with Helm?
So we're trying to make sure everything is automated. We want to make sure that all of this stuff is being done by a service and not necessarily by us. So if we're doing it, we're actively trying to write something to that to make sure that we're not touching it directly, especially when it comes to production. We really, really, really hate touching production systems. So
The biggest thing is we've got a series of controls and stuff. We want everything to be self-service. So for different services based on their mission critical tier, what they're doing, what they're supporting, we'll have different routes, but we'll have like automated checklists that it'll make sure, okay, have these three things been done? Okay, that can move to staging, and then there'll be a different checklist for staging to prod. That's what we call our pipelines, is the definition of those checklists from commit to prod. And again, we try to automate every piece of that, and the pieces that aren't automated are self-service. And there's a lot more I could say on that. I would love to keep going, but I know we're coming up on time too.
We probably have time for two more questions. There's a gentleman in the back, and then there was someone up here in the front. You'll be the last one.
okay. You want me to throw the other slide up here?
Oh yeah. Everybody knows we're doing questions. So.
Thank you. Regarding load balancing and networking, which CNI plugin are you using in the Kubernetes environment on premises?
It's Calico.
Yeah, we're running the Calico that ships with UCP, and then we've got a F5 load balancer using the plugin in front of that.
Okay, why don't we call it a wrap? With that, please thank them.
Thank you,
Mike
guys.
and Don, greatly appreciate it. Thank you again.
All right. Yep. Thank you.